We will solve the following exercise. Exercise is a number 2.42. The magnitudes of the forces exerted by the cables are T1 equals 2,800 pounds, T2 equals 3,200 pounds, T3 equals 4,000 pounds, and T4 equals 5,000 pounds. What is the magnitude of the total force exerted by the four cables? All right, so basically what we have right here is 1, 2, 3, and 4 cables. The four of them are actually applying force on this body, right? And the problem is asking for the total magnitude of the force exerted. So what we're going to do is that first we're going to determine the total force exerted on the x-axis, then on the y-axis, and finally using those two components, x and y, we will be able to determine the total force exerted. Now, how are we going to do this? Well, as always, I'm going to solve the exercise. Next step, explain what was needed for me to solve it. All right. So, for T4, we have a 51 degrees angle. That means that, well, actually a bigger title would be 4x, the x-axis. So I'm going to say that this is 5,000 times the cosine of 51. And right there I'm going to find this component. Let me put it a little bit bigger. Well, not that much. This component is the one that I'm going to locate. Now, for T3, I have 4,000 times the cosine of 40, and it's basically the same equation for every single one of the cables. So for T2, right here I have 3,200 times the cosine of 29. And finally for T1, I have 2,800 times the cosine of 9. And this is going to give me an answer, an answer, an answer. Now, for y, for T4, it is basically the same stuff, but regarding, I'm not going to write every single one of the titles because I already did it. So this is 5,000 times the sine of 51. The same thing goes for this. Okay, sorry, 4,000 times the sine of 40. 3,200 times the sine of 29. Finally, 2,800 times the sine of 9. Now, the answers. First one. So 5,000, make sure that you are working on degrees. So 5,000 times the cosine of 51 equals 3,146 0.6019. Now the same thing, but using the sign, equals 3,885 times, I'm sorry, 0.7298. Now 4,000 times the cosine of 40 equals 3,064.1777. Now with the sign, equals 2,571.1504. Now 3,200 times the cosine of 29 equals 2,798.783. Now using the sign, 1,551.3907 should be red, color red. Now 2,800 times the cosine of 9 equals 2,765.5273. Now the sign, 438.0165. And that's it, guys. We just have to add those components together, and at the end we will have the summatory between all the components. So what I'm going to do is that I'm going to do it once again, the final results, for me to determine that I didn't make a mistake during the calculator process. And I'm going to save the results on every single slot within the calculator. All right, so we're going to do it together. So 5,000 times the cosine of 51 equals this. So I'm going to press Shift Storage and save it within the A storage. So for when I look for A, it is going to show me the result. Now 4,000 times the cosine of 40 equals this. Okay, it was correct. So Shift Storage now within B. 3,200 times the cosine of 29 equals, yeah, it is correct, Shift Storage within C. And finally 2,800 times the cosine of 9 equals this, Shift Storage within D. All right, now same stuff for the y-axis. 5,000 times the sine of 51 equals, it was correct, shift storage, E within E, 4,000 times the sine of 40 equals this, shift storage within F, 3,200 times the sine of 29 equals 1,551.3907, etc. Shift storage within X, in X, and 2,800 times the sine of 9 equals, okay, it was correct, shift storage within Y. Alright, so I'm going to add A plus B plus C plus D. Alright, so the total amount is 1,1775.0901. And now I'm going to add E plus F plus X plus Y. 8,446.2870. Sorry, no, I'm out of space, but I like to use 4 significant digits after the comma, which means 1, 2, 3, and 5. I'm sorry, 1, 2, 3, 4. I do not know what happened there. Now, we have the first component, the second total component. At the end, we have basically that, for example, I'm going to call it TR for the total result, is equal to 1,1775. It was correct? No. Oh, 11,000. I'm so sorry, I didn't know how to read this number. 11,775. I apologize. 0.0901 along the x-axis plus 8,446.2875 on the y-axis. This is like the vector regarding the components. And finally, I am going to be able to determine the total force exerted by determining the magnitude of the vector. So basically, I don't have enough spaces. So for example, this result, I'm going to save it within M, right? And this other, for example, I'm going to save it within A. I know that I'm going to change the value for A, the one that we previously had, but I don't need it anymore. So basically, the final result is the square root of M square plus A square. A square. The total force exerted is equal to 14,491.1186. This is in pounds. Let me check if there's any mistake. I don't think so. So yep. Right guys, this is how you can solve this exercise. Remember, all you have to do is to take into consideration the two components regarding every single one of the forces being applied to every single one of the cables. For example, this tension, I have to determine the X component, which is this one, and the Y component, which is this other, right? And finally, I have to do it for every single one of the cables. All right. At the end, you just have to do a summatory between every single one of them that involves the same axis, as I did here, and the summatory is going to be equal to the final resulting vector. That could be, well, we will be able to determine the final vector, the magnitude and the angle, but for example it could be something like this or this. The important thing is that the resultant vector, this vector, has this component along the x-axis and this other along the y-axis, and finally the final magnitude. Alright guys, this is how, once again, this is how you can solve this exercise.